Okay. Let's do a couple as a review from yesterday. Sometimes you're just told things, and we didn't have any of these yesterday. Like if it tells you y is -2, then guess what? Y is -2. Like you don't need to do anything. So then you really only have to go to the other equation, substitute the -2. Oops, pause 18. Substitute that -2 in. I'm going to subtract 6 from both sides, and then you know x is 3. Okay, all right, this is more like what we did yesterday. If we go to the second equation, and everywhere there's a y, we plug in a 5x minus 7. Let's subtract 14 from both sides. Divide both sides by -13. X is 2. Come right here. Our y is 5 times our x minus 7. So our y is 3. And remember, when I'm doing these videos, I go through it really fast because you have a pause and rewind button. It's just to it's just to get it out here where you can see it. One thing I do want to mention right here, though, let's see if I can change colors. If you had an equation like that one, see how it's every single term is negative? Do y'all realize you could turn it into that before you started? Because you could just divide both sides by -1. Or you could think of it as moving things to the other sides. Like if you like positives better than negatives, then and you have an equation, you remember equations, you can do whatever you want. All right, but here's the new part for today. What if you don't have one of these that's already solved for a variable? Well, then fix it. Like this thing right here, if I wanted y all by itself, I would just take that 5x to the other side. So I'm not going to look at this anymore. I'm going to look at that. And now I have something I can plug in for y. So 3x, take away 40x, that's -37x. I can go ahead and subtract 24 from both sides. 0 divided by anything other than 0 is going to give me 0. So my y is -3 plus 5 times my x. 5 times 0 is 0. So y is -3. Okay. So your goal here is like, let's figure out what equation you want to look at and then what variable. I'll be honest, I would take this one and move the y to this side. The only reason, like I know there's a y sitting right here that I could say y is 6 plus 4x, and that's not hard at all. But when you took that and plugged it in here, there's lots of mistakes to get made. Like, well, and we could do it both ways if you wanted to, but you'd have to be subtracting the entire 6 plus 4x, and that's where people mess up. So personally, I recommend let's take that one into this and then go plug that in for y. So it says we're just adding what that y is, which means just keep it like it is. I can add 21 to both sides, divide both sides by -9. There's x. Y is -5 times x minus 21. Oop, that's positive 15. So y, -6. Okay, and I haven't been doing it every time, but remember, go back to the original problem. -4 times my x plus my y, it's supposed to be 6. It is. -5 times my x minus my y is supposed to be 21, and it is. Okay. All right, this one, you're going to take that top equation, rearrange it for y, and then go plug that into the other. I'm going to go ahead and add 12 to both sides. Divide 0 by 27, we still got 0. And then right there, my y is negative 2 plus 5 times 0. That's negative 2. So that's not tough. The thing I want to bring up on this problem is, look at this one. Okay? Whether you see this or not, it doesn't matter. You'll get the right answer. I just want to know for everybody who feels comfortable doing this, notice how 3 will go into every number in that equation. Like if you wanted to divide both sides by 3 before you started, you could. Because it's an equation. You can do whatever you want. Add, subtract, multiply, divide, as long as you do the same thing both sides. So just know that's a possibility. All right, this one, I'd pull the y over here, bring the 9 to the other side, and use that. Take that, plug it in for y. Sorry, I'm eating my breakfast. Add 18 to both sides. 36 divided by 9 is 4. Right there, my y is negative 2 times my x plus 9. Y is 1. So the ordered pair, 4, 1. Now this one, you do not have a variable just sitting there by itself at any point in time, but you do have an equation down here where every single number in it will divide by 3. So what if I divided both sides by 3 to start? Then I'd get x plus y is negative 1. And then I can just rearrange for either one I want. And I'll take that, plug it in the other. Here's a negative y. If I subtract 3 from both sides, if the opposite of y is negative 1, then regular y is positive 1. And then x is negative 1 minus that 1, which is negative 2. All right. And then last but not least, going back to the little bit of the graph and stuff. When we've drawn 2 lines when we were solving systems, so far, one of 2 things has happened. Either the lines intersected and we found a solution that was an ordered pair, or the lines didn't intersect because they were parallel and we figured out there was no solution to that system. Okay? So here you got one solution, which is an ordered pair. Here we have no solutions. Is there anything else that could happen? Well, let's try this. All right, let's grab this one, which I'll rearrange it. Rise 2, run 1. Okay. All right, and we'll swap colors. This one, if I divide both sides by 2, I get the exact same line. Like it's just going to be on top of the other one. Remember, the whole thing about a system is that we're finding the ordered pairs, the x paired with the y, that satisfies these equations. Well, the exact same points satisfy those 2 equations because when I graph them, it's the dadgum same line. Okay? So there are, like if I said how many solutions, there are infinitely many. But if I said, what is the solution? You can't just say everything works because, that point right there, not a solution. So you can't just, it's all the points. It was all the points on the line. So it's any ordered pair that satisfies y equals 2x minus 3. Now we have a math way of saying this. You put these little set markers. So it's the set of all ordered pairs. And then they draw this line. And when you draw that line, people say such that y is equal to 2x minus 3. So it's just every point that's on that line. So if we come back up here, what's the third thing that could happen? They could be the same line. Which means there's infinitely many solutions. And it's all the points on whatever line we're talking about.